Alright, now it's time to put together everything that you've learned so far about modeling atoms and molecules. So far, you've learned how to draw Bohr models of atoms. That's where you put the name of it in the middle and draw the electrons around it in the correct shells. And you've also used ball and stick models to create models of molecules. Now we're going to combine those two things in the activity called developing and explaining models of molecules. So let's start with water. That's on the front page of your packet. I'm going to explain how to do this, and you can follow along and write down all these things in your packet as well. So to start, it asks you to develop a simple model of a water molecule. Water is H2O. You've already made a simple model of a water molecule several times. You did it on your last formative assessment, and you also did it as part of the ball and stick model activity. If you remember H2O, my O goes in the middle. O stands for oxygen. This is a bent molecule, which means that it's not straight. The H's move towards each other a little bit. And I'm drawing my bonds because they're sharing. This is my simple model of a water molecule. It should look pretty familiar to you. Now the rest of the things that we're going to do are going to help us check this simple model to make sure that it is correct. So moving on to question number 2, it says to explain the model of a water molecule that you created above by answering the next 3 questions. Part A says name the types of atoms that make up a water molecule. H stands for hydrogen. So I'm going to write hydrogen. NO stands for oxygen. You guys have told me that on multiple occasions before. And if you didn't know what these things stood for, what the symbols stood for, you could go to your periodic table and you could look. So we had H and O, so I could find the H, and if you see, its symbol is H and its element name is hydrogen. That's how you could figure that out if you didn't know it. You could do the same thing for O. Find the O on the periodic table. Here's the O, and its name is oxygen. Part B says how many of each kind of atom are in a single molecule of water. So for that one, we got to count. Now you could come back up to your simple model and you could count. I have 1 H, 2 H's. So 2 hydrogens. But like we've talked about before, you can also get that from looking at the formula for the molecule. The little number comes after what it's talking about. So since the 2 is after the H, that means I have 2 hydrogens. And since there's not a number after the O, that means that I just have 1. Okay, 1 oxygen. So 2 hydrogens, 1 oxygen. All right. That part should have been a pretty good review of what we've already been doing. Now we're moving on to more of the new stuff. Part C says to draw each of the atoms with their electrons in shells, then explain why they bonded to form a molecule. So every time you do this, you need to draw out that little table like we did when we were practicing modeling atoms. So we know that we have oxygen. Oxygen needs blank total electrons. Now, to figure that out, remember we can go to our periodic table. If you remember from a while ago, when we practiced this a bunch, The number of protons tells me the atomic number. So if I find oxygen, here's oxygen, its atomic number is shown in the top corner, and its atomic number is 8. Now, the number of protons is equal to the number of electrons. So if I have 8 protons, that means I also need to have 8 electrons. So oxygen needs 8 total electrons. Then we got to worry about its shells. So first shell, second shell, third shell. Okay, remember, electron shells can only hold certain numbers of electrons. The first shell, the most it could hold is 2 electrons. You always start by filling that one up. So we have 8. We're going to give 2 to the first shell. So 2 electrons to the first shell. And we have 8 minus 2 equals 6. I have 6 electrons left. The second shell can hold 8. And since 6 is less than 8, all 6 of these electrons can fit in the second shell, which means I don't need the third shell. Now we're going to do the same thing for hydrogen. So we're going to write out what hydrogen needs. Hydrogen needs You always want to start by writing this information out. It will help you make sure that your models are accurate, which is so important. Hydrogen needs blank total electrons. Now we got to go to our periodic table. We got to find hydrogen. Hydrogen's over here. Its atomic number is 1, which means that it has 1 proton. And since the number of protons is equal to the number of electrons, that means hydrogen also only has 1 electron. Hydrogen needs 1 total electron. All right, then we can write out our shells. First shell, second shell, third shell. Remember, the first shell could hold 2 electrons. Since it can hold 2 and I only have 1, that's where it's going to live, 1 electron. And then 1 minus 1 equals 0. I've used all of my electrons, which means I will not need the second shell or the third shell this time. Now that I've got this all drawn out, I can start modeling it. So, if you remember from our formula, we need to have 2 hydrogens and 1 oxygen. So, we're going to come down here, make sure we have some space, and we're going to draw these out. We're going to start with our oxygen. If you remember the Bohr diagram, we put the symbol in the middle, so I'm using oxygen. Then I draw its shells. Up here we decided that it needed 2 shells to hold all 8 of its electrons, because 6 plus 2 is 8. So I'm going to draw those 2 shells. The first shell needs 2 electrons. Electrons are negative. They're like magnets, remember? So they don't like to be close together. So we're going to put them far apart. 2 electrons in my outer shell, or inner shell, first shell, has 2 electrons. Then I'm going to move to my second shell. Up here we decided that oxygen had 6 electrons in its second shell. So I'm going to come here, my first shell is full, so I move to my second shell. It needs 6. I'm going to start at the top. 1, 2, 3, 4, 5, 6. 6 electrons. But remember, it wants 8 for this outer shell to be full and happy, which means it's going to need 2 more. So we're going to make ourselves a little note. We're going to say that oxygen has 6 electrons in its outer shell, but it needs 8 electrons there to be happy. That means oxygen needs 2 more electrons. Now, you might be wondering where oxygen is going to get those electrons from. Well, it's going to get them from the hydrogens, and that's why it bonds. Because when it bonds, they can share. So we're going to start modeling our hydrogens. We're going to put 1 down here. We're going to put 1 over here. And the reason we're going to do that is because if you notice, these electrons, they already have buddies. They already have friends. They're partnered up, this one and this one. But this one in the outer shell is lonely, and this one in the outer shell is lonely, which means they both want a new friend to share with, to bond with. So up here we decided that hydrogen only had 1 electron, and it would live in its first shell. So I'm going to draw 1 shell around our hydrogen atom. And then on it, I'm going to put the 1 electron the hydrogen has. Here's his 1 lonely electron. Then I got to come over here and do this hydrogen. Here's his lonely electron. Now, just like we made this note about oxygen, we're also going to make a note about hydrogen. We always make these notes the same way. Hydrogen has 1 electron in its outer shell, but it needs 2 electrons to be happy. That means hydrogen needs 1 more electron. Since this is hydrogen's first shell, it did only need 1 more to be happy, because then it would have 2 and its shell would be full. So where is it going to get that 1 that it needs? Well, I'll show you. What's going to happen is it's going to bond. So this hydrogen down here is going to share 1 electron with this oxygen atom. And we show the bonds by drawing a circle around the electrons that they're going to share. So now these electrons are buddied up, which would give oxygen an extra 1 and hydrogen an extra 1. They share them. Then we got to do the same thing over here. This hydrogen has 1. It needs 1 more. So it's going to share with this oxygen. We draw the bond. And now if we look, they're sharing. So now if we count, oxygen has 1, 2, 3, 4, 5, 6, 7, 8. So it's full and happy thanks to the 2 that it got from the hydrogens, 1 from each hydrogen. If we look at this hydrogen, it has 1, 2 electrons thanks to the 1 it got from the oxygen. And the same thing for this hydrogen. It has 1, 2 electrons thanks to the 1 it got from oxygen. Since each hydrogen only gave oxygen 1 electron to share, We call these single covalent bonds. There are two single covalent bonds in a molecule of water, one between this hydrogen and oxygen and one between this hydrogen and oxygen. Because they're sharing electrons, we call it a covalent bond. Covalent means that they share. So we can also write they share once they share, everybody is happy, and we have a molecule. This is the same thing you're going to do for all of the rest of the pages in your packet. While you're working, please pay close attention, use your periodic table, and come back to this video anytime you need help. Right now, I'd like you to turn the page. The next page asks you to do the same thing, but for a molecule of chlorine. This is Cl2. And when you write chlorine, anytime you write it, usually write it like this, capital C, and then a loopy L. Because if you draw it like this kind of looks like an I, and it really isn't. It's Cl. When you go to the periodic table, you are looking for Cl. You're trying to find Cl, chlorine, which is right here. Okay, so keep that in mind. I want you to pause this video, and I want you to go through and complete this page. When you're all done with the page, you can push play and check yourself. If you're doing okay and you're getting it and you understand it and you had it correct, that's great. You can move on and continue working and get the packet checked when you're all done. If you're struggling, I highly suggest asking a teacher for some help and some guidance on one or two of the next molecules before you continue working on your own. Right now, pause the video, answer this page, and then push play again to check your work. Welcome back. Since you pushed play again, I'm guessing that you finished your page about chlorine molecules. So I'm going to walk you through it. We'll go a little quicker this time since you already sort of know what to do. So when we make our simple molecule, remember, we start by drawing them. So I have Cl. Remember, our L's are loopy when they're lowercase. And I have a little 2 here, which means I have another one. So I need another Cl. And then I just need to bond them. So I'm just going to connect them. That's your simple model of a chlorine molecule. Then we come down here and we're going to explain the model of a chlorine molecule that we created. So it says name the types of atoms that make up a chlorine molecule. Well, we just have one. It's Cl. So if I go to my periodic table and I find Cl, I can see that its name is chlorine. In case you were wondering, Cl2, the molecule we're making, is the kind of chlorine that's in a swimming pool. So we have chlorine. It's the only kind of atom in here. How many of each kind of atom are in a single molecule of chlorine? Well, there's a little 2 here, so that tells me there should be 2, and I can check that in my simple model, 1, 2. So I have 2 atoms of chlorine. Now we're on to part C. Part C is where you have to draw it all out. So we got to start by figuring out, what does Cl need? So Cl needs blank total electrons. Got to go back to my periodic table, Find chlorine again. Its atomic number is 17. That tells me there are 17 protons in an atom of chlorine. And since there are 17 protons, that means there are also 17 electrons. So we're going to put a 17 here. Chlorine needs 17 total electrons. Then I need to write out the shells. The first shell the second shell, and the third shell. "17 total is what we're going for. Remember, we start with the first shell always. So the first shell, the most it can hold is 2. And since I have 17, I know I have to fill it up. So I'm going to put 2 electrons in the first shell. I had 17. I'm taking away 2. That leaves me with 15 more electrons to put in here. The most that can fit in the second shell is 8. And since I still need 15, they're not all going to fit. So I know I'm going to fill up the second shell. So I'll give it 8. So then I'm going to subtract 8 more. 15 minus 8 is 7. That means there are going to be 7 electrons in my third shell. And that works because the most the third shell could hold is 8. So there's still room for 1 more. I'm going to check my math and make sure I got them all. 2 plus 8 is 10, plus 7 is 17, which gives me my 17 total electrons. That means we're ready to start drawing. So we're going to start drawing our molecules. We are going to put Cl in the middle. I need 2 Cl's, remember, from up here. And like we just figured out, they each need 1, 2, 3 shells. So I'm going to go ahead and draw those. 1, 2, 3 shells. 1, 2, 3 shells. Then all we have to do is put our electrons on. So my first shell needs 2. I'm going to do 1 atom of chlorine at a time. So there's my 2 shells in my first chlorine, or 2 atoms in my first shell of my first chlorine atom. Then I move to the second shell. It needs 8. So I'm going to go around in circles. I'm going to go 1, 2, 3, 4, 5, 6, 7, 8. Now that one's full, and I can go to the third shell. Our third shell needs 7 electrons. So again, I'm going to go around in a circle. 1, 2, 3, 4, 5, 6, 7. Okay, then that one is done. I'm going to count them to make sure I got all 17. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Always double check your counting to make sure that you get them all, because you'd hate to get something wrong just because you forgot to draw an electron. Now I have to do the exact same thing to this atom of chlorine. So I start by filling up the first shell. It needs 2. 1, 2. Then the second shell, it needs 8. 1, 2, 3, 4, 5, 6, 7, 8. Then the third shell, it needs 7. 1, 2, 3, 4, 5, 6, 7. All right, now I got to count again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So both of my atoms of chlorine are done. Now I have to bond them. I got to show their bonds. This electron right here in the third shell is lonely, and so is this guy over here in this third shell. So I'm going to draw a circle around them to show the bond. They're going to share electrons, which will give them both 8 in their outer shell. And I know that because we can write out our little note. We can say chlorine has 7 electrons in its outer shell, and it needs 8 to be happy, so it needs 1 more. Each chlorine needed 1 more, and they get that by sharing. So we can say that they share 1 electron each to form a single covalent bond. And unlike water, where we had 2 things that bonded, and we had 2 single covalent bonds, here we only had to draw 1 bond. So here we have 1 single covalent bond. And now that we have that, both of our chlorine atoms are happy, and they have joined together to become a chlorine molecule. Now, if they had to share more than 1, we would just name it differently. Instead of being a single covalent bond, you can think of an ice cream cone. So, when you go to the ice cream store and you want to get an ice cream cone, you can get a single scoop of strawberry ice cream or whatever flavor you want to get. Single scoop. That means you're getting 1 scoop. Single. Or if you don't have a boyfriend or girlfriend, you are single. You're by yourself. Now, if I'm really hungry and I go to the ice cream store, I might want to get 2 scoops of ice cream. And the way that I order that is by asking for a double scoop. Double means 2. So if I had to draw 2 rings between the same 2 atoms to show that they were each sharing 2 electrons, I would call it a double bond. And if you want to get really crazy, there are even triple bonds, which would mean that the atoms are sharing 3 electrons with each other. So here is my 2 atoms, and they would have to be sharing 3 if it was going to be called a triple bond. But anytime they share, no matter how many it is, we call it a covalent bond, because covalent means that they are sharing. Later on in your schooling, you'll learn about other kinds of bonds. So single bond is if they share 1 electron each. A double bond is if they give and share 2 electrons each. And it would be a triple bond if they give and share 3 electrons each. But in 6th grade, we won't really be dealing with this one so much. We'll be focusing on these 2. The single bonds will be mainly for your proficiency questions when you're making your initial simple models, and then the double bonds will come into play for your proficiency questions on your assessments when it asks you to use what you know to predict what another molecule would look like. Double bonds happen in more complex molecules. That's the end of this video. As I said before, I would like you to work through the rest of this packet. If you did not get this model of chlorine correct, Instead of doing the next one on your own, I would like you to go ask a teacher for help, and you can sit and they can explain that one to you. If you did get this model of chlorine correct, you can continue working on your own and just let us know if you have questions. Otherwise, we'll check the whole packet when you're done with it. Good luck!